Okay, so I have 1:45, so I'm going to get going. I tend to be kind of long-winded anyway, so hopefully I manage to get in within the time. The name of this session is Oozie or Easy, and it's really focusing on an alternative to Oozie or any workflow management tool that you may have in your environment, specifically for Hadoop, although much more broadly based, as you will see. My name's Joe Goldberg. I'm a member of Control-M Solutions Marketing at BMC Software, and Control-M is the tool that I'm going to be talking about. I think that most will agree that Hadoop has gotten quite its fair share of hype. There's a tremendous amount of interest. Almost every organization of any substance that has any kind of a technology or an IT environment is looking at Hadoop as technology to be able to deal better with the data that it has. And so I think it's fair to say that the level of interest in Hadoop is very high. But at shows like this and in conversations with customers and sort of anecdotally, we know that there are still relatively few, considering how much interest there is in Hadoop, that have actually gotten Hadoop into production. It's still kind of in the domain of trying to figure out how to best leverage it, how to best deploy it, what are the best practices, a variety of other questions. And of course, whenever there's a question like this, there's always going to be some analyst reports or polls that are taken, and there's certainly no exception here. There's quite a number of things you can look to that there are a variety of challenges that are frequently cited as to why an organization has not yet sort of broadly adopted Hadoop. And one of the things that comes up is the challenge of kind of getting it absorbed into or integrating with their existing environment, their existing infrastructure and technology and application stack. And of the difficulties that are so described, this happens to be a statistic or a graphic that comes from Hortonworks. Some of you may have seen it if you're on their email distribution lists, that of the major reasons or problems that customers have with Hadoop, implementing Hadoop, one of the things that is cited consistently in terms of the number of cases and problems that are reported to Hortonworks is executing jobs. And you know, you can get into the whole discussion of whether Hadoop is batch or not. You know, Hadoop 1 was pretty much completely batch. Hadoop 2 is multi-tenant, multi-application. You could do a lot more than just batch. But just like in the sort of typical or traditional IT environments or technology environments, batch continues to be a very major component of how people run work in a Hadoop environment. So it doesn't really matter if it's only 20% or 50% or 80% of your work. Batch and running jobs and managing them is a big deal, whether you're dealing with Hadoop or any other environment. And another thing that people find very quickly when they start looking at Hadoop is that, like most technologies, it is additive and it integrates with a lot of stuff. By definition, when you're dealing with data, if you're looking at Hadoop, you probably already have a whole ton of data. And although the hype is around new types of data, you know, unstructured data, social media, machine-generated data, there is still, and for some companies predominantly, a ton of conventional data. And so many, if not most, Hadoop projects have to deal, and I would say big data projects, have to deal not only with this new kind of data, but also sort of conventional data, either ingesting it, outputting back into those existing applications. And so if you look at what is a typical Hadoop project, you know, what is the activity? It starts with a bunch of conventional data. It may be enriched with social or machine-generated data or logs, but there's also still a lot of ETL. And so, you know, there's a predominance of this kind of processing of data flowing into Hadoop being processed in Hadoop, and then I would say the output is in sort of two major categories, either for human consumption, perhaps ad hoc queries, analytics that are being done, but also sort of repetitive stuff that is either then being fed back into some other applications or is being generated into some kind of reports or dashboards or tools. And so this is kind of the way, you know, sort of this kind of complex interconnected data flow exists. And you know, this is a very generic diagram. You can probably say that almost any technology application project looks very similar to this in some way. So what's the sort of anecdotal experience that we have that we've been hearing from customers? They start a project like this, whether it's to learn Hadoop and it's just kind of a POC or a research project, or if they've identified business cases and they're now working on it, they start working on a project like this. They're ingesting or have to work with some kind of a relational database. Doesn't matter which one you pick, they're all kind of very similar in nature. Let's say it's SQL Server in this particular case. And the process of managing or dealing with that data within the context of the project means that they're going to be doing some kind of SQL querying or writing SQL scripts. They may have stored procedures. It doesn't really matter, you know, what the variation is, but they're working with that kind of a relational database. And if it's, in this particular case, it's SQL Server, in order to run that work, to do it repetitively, because, you know, even if you're just doing development, you very quickly get to a point where you're doing some things repetitively, and what better way to do things repetitively than to run it as a batch job? And so you have to learn, in this case, SQL Agent, which is the component of SQL Server in the way it runs jobs. You have to define that job, you have to learn that tool, you have to learn that technology, and that's kind of how you do it. There's ETL processing that you're probably doing that you might want to either somehow connect to Hadoop, perhaps replace partially with Hadoop. And so let's say you're using Informatica, pretty popular ETL tool. Same kind of a process, right? You've got to build your workflows in Informatica. Then you've got to, if you want to run this repetitively, either in a production or even initially in testing, you've got to learn the Power Center scheduler. You've got to build that job. You've got to run those jobs, and you've got to learn that tool. Okay, let's say you're dealing with files coming from wherever they happen to be coming, whether it's machine-generated data, whether it's feeds from social media sources, wherever and however they're coming, you're going to have to move those files around, at least some. Part of, and probably one of the most popular ways to move files around, is with some kind of FTP tool. Whether you're running conventional FTP, whether you're running SSH, or some various flavors of that. And of course, you can kind of see where this is going. There's going to be yet another tool. And you're going to have to figure out how to use it and drive it and get familiar with it and probably set up some way to run it. And so now you have got your data perhaps in Hadoop. And you are learning Hadoop. Well, you probably figured out that you can now repeat and iterate. And this is the Oozie part. I've had actually some conversations about how good Oozie is, and I can tell you that based on an informal poll that I have to admit that I took, people aren't crazy about Oozie. For anybody who loves Oozie, I always point to the fact that somebody had to build Hue on top of it, which I think is kind of evidence that maybe Oozie has at least one or two minor deficiencies. But nevertheless, in the Hadoop environment, and again, it doesn't really matter if it's Oozie or Azkaban or Luigi or Talend or a million other ways that people say they run workload in Hadoop, the same thing is going to be true. It's yet another tool that does only that particular piece, and you've got to learn how to use it. You might have to do a lot of scripting, and you have to then, after you build whatever workflows you build, you're going to have to run them. You might begin to see the problem that this kind of a situation causes. Imagine having to operationalize this stuff. Go to your system administrator, your IT ops person, whoever it is that's going to be responsible for running this stuff if it isn't you, and even if it is you, this is kind of the way this is going to look. There's a whole bunch of tools. Each one of them is different. not only do you have to learn how to run them and manage them, but you also have to find a way to somehow manage the dependencies that are going to exist. You know, you have some data, you do the file transfer or something like that, you may be able to watch for that event or not if you're depending on successful execution in one tool and then starting execution in another. If these tools don't know about each other, you're going to have to be relying on somebody to do that manually. And you have to pretty much start this right from inception when you're building or developing your application. So it's not even just an operationalized challenge. It can become somewhat difficult even in the initial building and development phase and when you have to do testing. One of the interesting conversations that I've seen, and I think this is a blog that somebody posted, is like, you know, what are the requirements for a workflow management tool or platform or framework? And so these are some of the interesting characteristics that have been identified. Not only was this something I found in a particular blog that was posted, but in conversation I hear this over and over and over again, that this is the kind of thing that an ideal workflow management tool, at least from a perspective of one developer or a few developers, should have. And if you then look at these and kind of align them with the capabilities of a tool like Oozie or any similar workflow management tool in the Hadoop environment, you will find that quite a number, I would say the majority, are absent. So what do most programmers do? Well, most programmers, developers, whatever you want to call them, they know how to solve this problem. They're going to develop. And the way they do that is by generally writing a bunch of scripts. So I don't know if all of you guys that are developers write scripts quite as fast as this, but eventually you wind up developing a whole bunch of scripts. Generally, you might put them all into what one of our customers has called a mega script, and that's what you're going to run. Now, you remember you had to build this. This is a very modest collection of scripts. Most typically that you see running are going to be considerably larger, more complex. It's not trivial to develop this stuff, and you got to write it, you got to test it, you got to make sure it runs. So this becomes part of the development effort. So if you planned to spend a day or a week or a month developing your big data or Hadoop application, you may find that this extends that by 10, 20, 30% or even more. And then, of course, the real problems begin, because eventually this stuff is going to have to run. The more complex, the larger, the more technology that has been sort of incorporated into this script, the more of these kinds of challenges you're going to face. If you're running scripts individually, you have a problem of trying to understand what exactly are the relationships among all of these things. If that script, let's say, runs for an hour, after 55 minutes, can anybody tell whether you're almost done or whether something went horribly wrong and you're looping in the very first statement? Very difficult. Bit of an extreme case, but to make a point. So it's hard to know. Then, what if something breaks? Yeah, I know we're all great coders. Nothing's ever going to break, but it does, right? It's an environmental problem. It's not necessarily our code. Who's going to look at it? Well, it pretty much has to be a developer, right? And ideally, the developer or the developers that wrote it, but they may not be available. So somebody else has to look at it. Now you're no longer just debugging the problem that has occurred. You're trying to either debug or understand somebody's code. While there may be a problem that some business user is waiting to be solved. You found that there's a problem. Where's the output from all this stuff? Well, part of that scripting that you might have done has been a lot of code to put output somewhere. And eventually, somebody looking at your script is going to figure out where that somewhere is. You may or may not have access to it, but let's say you do. Your problem is 2 or 3 scripts. Guess what? Each one may have put the output somewhere else. You have to go figure that out. How do you fix this thing? It broke somewhere in the middle. Can we just run it again? Probably not. We might have to do some other things to fix it. And once we do fix it, we pretty much have to start from the beginning. If it did run for 55 minutes out of the hour, you probably have just lost 55 minutes. Again, all of these are sort of extreme examples, but they're meant to stress and sort of emphasize the point that there are a lot of operational challenges with this kind of an issue. And when you build this stuff, I can almost guarantee that most people, when they're in initial phases of building applications, they're not going to be thinking necessarily about how do I send notifications, how do I open up what could be a problem ticket, which is a requirement in some organizations for a production application. There's a variety of other things that have to be done that either somebody's going to have to go back and add some more code, and then you kind of increase and repeat the cycle or not. So that's really the challenge that I want to discuss sort of for the remainder of the few minutes that I have here, is that how do you get this kind of stuff operationalized? And in the process, hopefully, actually accelerate the time or reduce the time, and so accelerate your ability to get these applications developed and into some kind of operational state, because everybody needs to be doing this more and more frequently with less and less time than ever before. So we think we have a better way, and that's Control-M. So Control-M is a workflow management solution that has come to the Hadoop space from the opposite end of the universe, so to speak. We have been an enterprise scheduler for about 35 years, and we support everything in the world pretty much. And I hope to be able to defend that statement shortly. And we've added support for Hadoop, native support. So the way we support applications, when we add native integration, it is just that. We embed or use the native APIs of the application we're communicating with, so that we have deep knowledge and understanding of how to connect to it, how to run work in it, how to track it, how to gather its output. And we do it in a consistent way so that it is very easy to set up, saves you a lot of work, gives you immediate sort of best practices out of the box, and you get this kind of uniformity. So I showed you these screenshots here so you can see that for the examples I gave, and they really are just examples. So we support not only SQL Server, but also Oracle and Postgres and MySQL and pretty much every relational database that you may be aware of. We support almost every major ETL application, and so forth and so on. So these are really just representative examples. And if you think about how you have to run a job and the things that I talked about, determining whether something succeeded or failed, gathering output, managing relationships or predecessor-success relationships, those things have absolutely nothing to do with the work that you're running. That's generic. And it doesn't matter whether you're running 2 MapReduce jobs or you're running a MapReduce and, take an extreme case, a mainframe job. Relationships done the same way, general success or failure criteria is done the same way, notification, and so gathering output, opening service desk or help desk tickets, that's all the same. And so that's the approach we've taken. Everything else is part of the capabilities that we deliver, and we continue to add this native application integration so you have the benefit of this kind of consistency as we add new support for new applications. So this is what it looks like. My goodness, it's not my computer. I can immediately I don't know what happened. Well, that's going to be an interesting presentation. Okay, so hopefully you got to see at least a little bit of the way we manage workflows, which is, from a logical perspective, what we show you is sort of the business relationship independent of the technology that you're managing. Perhaps you saw that it's kind of a flow chart, which is the actual flow of and the relationship of the work that we're managing. It uses what we call management by exception. We use color to indicate status so you can see visually. You can click on any object that represents a job in any environment. You can look at the output. By default, we manage success or failure, which is determined as either an exit code, condition code, completion code, whatever the technology calls success or failure. Wow, okay, we're getting there. But you can also override it. So you can tell control M that go to slide. Oh, okay, I'll go to slide. Okay, I'll do it, I guess. This shouldn't take too much time. Apologies. Ah, okay. Yeah, so what you see behind every rectangle is a job or a process, depending on the technology that is implemented, and it is intentionally technology opaque, meaning that each one of these rectangles represents a process, but you don't have to know or care what that process is. If you do, however, you have all of the detail that you need, and you'll see that momentarily. So you can click on, right-click on something, you can look at the output, you can rerun it, you can look at the output, you can look at the log, you can see the information from our perspective, the way we're managing it, as well as the job output. You can use that output to override decisions about success or failure. There's a ton of other functions, and obviously we don't have enough time to talk about it, but this is what it looks like to be able to define a Hadoop job. So every application that we support, there's a job palette. You simply grab the type of job you want, you drag it onto the canvas. When you open it, you get a form that looks like this, which has 3 sections that have all of the general stuff that I mentioned, where you can specify complex calendaring and success or failure criteria and all kinds of other analysis, post-processing, and a whole bunch of other stuff. And then there is an application-specific section. In the case of Hadoop jobs, this is kind of what it looks like. It's already been enhanced since this screenshot. And you can select the type of job that you want to run. So we support today MapReduce, Pig, Hive, Scoop, streaming jobs, Tajo if anybody happens to have it. In July, we will be adding support for Spark. We support every Hadoop distribution. We are partners with Hortonworks, Cloudera, and MapR, but we are also members of the Open Data Platform, and we support both Big Insights and Pivotal, and really any other Hadoop distribution that is based on the Apache distributions. We use common APIs, so the way we work with all of these is pretty much consistent. You can fill in or select the kind of job you want. You can then fill in some parameters. You can specify in pre and post HDFS operations in case you have to do some setup and cleanup. All of that capability is there. Of course, you can base this on events such as file creation or file arrival, deletion, all of those kind of things that are provided. And the process of building a flow, whether it is purely Hadoop or big data components or anything else, looks something like this. So this is the job palette that I mentioned. That job palette contains all of the job types that you have in your environment. By the way, you can manage that too, so you can hide jobs that you don't want people to see. You can create your own jobs, or job types, which I'll mention momentarily. And you just simply drag and drop the jobs that you want. You fill in the parameters. You can set templates so they could be pre-populated with the vast majority of the characteristics that are required, and then you fill in only the little bit that you need. You can add something we call SLA management, where you can specify either at the end or through at various milestones throughout the flow that certain targets have to be met, and we monitor for that. So, again, quite a lot of different capabilities. Specifically for SLA management, if you are building a typical Hadoop project, which is going to consist of a lot more or things that are other than Hadoop, you really have the ability to manage this both at a technical level as well as to elevate it and sort of look at it from a more holistic perspective, where you're looking at the entire collection of work as a service or a collection of jobs that you need to have done by a particular time. So you can specify when it must complete or arrive at a particular milestone, and we will monitor for that. Other capabilities that might be significant, things like version control or version and change management. So Everybody, of course, when you're building your initial project, you may not be thinking of it, but eventually somebody is going to have to maintain it and modify it. And there's a variety of change-related and sort of maintenance-related activities, all of which are provided for here as well. Some of the most important ones, I would say, just to highlight, there's certainly auditing, who changed what and when, the ability to also save any number of versions so that if you are running a particular version and you need to revert to another one, you can do that very easily to verify whether it was the change that was responsible for the problem. You can forecast how workload is going to behave. So you can take a flow and say, what is this going to look like sometime in the future? And then you can apply what-if scenarios to it. Because when you do that, typically you want to sort of model what's going to happen if you're going to make a change, either to your workflow or to the environment. And you have the ability with what-if scenarios to actually specify either that some of my workflow is going to run longer, or perhaps I may have fewer resources or more resources than I had when I last ran it, and how's that going to affect my workload. So you can do all of that. Another component that's a characteristic, I would say, of how we do all of our job management is a component called, or an object called, a connection profile. So for every application that you need to connect to, whether it's Hadoop or really anything else, there's some general information that is required. You have to know where your application is, where it lives, what ports it might be listening on, what libraries is it using. Now, if you're scripting, typically this is part of your setup. You might have to code that. The other issue is that, especially if you're just sort of investigating Hadoop, I don't want to say this too loud being at the event of a particular vendor, but you might be looking at multiple distributions. We can support all of that simultaneously in a single environment with connection profiles. So you can have an unlimited number of connection profiles. And whether it's Hadoop or any other application, you generally have a test, maybe in a prod instance. You may have version n and n+1 or n-1. You might be able, or you might need to be able to run work in all of those simultaneously, while you just build a different connection profile. If you do then rev your environment, you just update the connection profile. If you have security information or any information that you don't need or want to expose to everybody who's building workflows, you can put it in the connection profile. And so this connection profile not only becomes very expedient, but also could be extremely useful from a maintenance and sort of version control and access perspective. When the job goes into execution, so again, we saw the display shows colors, and there's a whole bunch of features that I can talk about for quite a long time, but a couple of things that I'd like to call out specifically. So a job, when it's either executing, when it completes execution, you have consistent and uniform access to all of the job output. So the example that I gave earlier, when you might have 2 or 3 or 5 scripts that are piping their logs out to some files somewhere, and you have to go hunting where those files are, we collect all of the output and we make it available directly from all of our user interfaces. Not only do we collect the existing output for the instance of the jobs that you may be running, but when something fails, it may be very useful to be able to compare to the way it executed last time, or 2 weeks ago, or a year ago. We have all of that available for you as well. The entire capability of monitoring and looking at and interacting with executing workflows is also mobility enabled. So you can look at this either from a phone or a tablet. There's also, it's accessible from a web view that is intended specifically for non-technical people. So if you have business users that either want to see what's going on with their workload or even to initiate their own workload, you can give them a capability to do that that is both controlled so that they don't do anything too crazy, but exceedingly simple so that they don't have to learn much in the way of technology and really can become sort of empowered to work on their own. Let's say you have made the tragic error of going down the road and building a whole bunch of Oozie workflows. We have an answer for you as well, and that is a conversion tool. Now, we've been in the business of helping customers move from whatever they were using for workflow management to Control-M for a long time. So you might see in the list up on top a bunch of tools that you may be familiar with or have heard before. So we convert all of those, again, for the purposes of helping customers either convert to Control-M or to, if they have a bunch of tools, to be able to consolidate. But we have added support for Oozie. So if you have Oozie workflows, you can use this particular tool to take those workflows and convert them to Control-M. The last thing I kind of want to talk about before I open up for any questions is that the Hadoop ecosystem is exceedingly dynamic. I think most of you, I hope most of you agree with that. Now, this is not radically different from traditional technology, but just at a faster rate. And so I said we provide, I think I said earlier that we support everything in the world. And I was going to say I'm going to defend that. Well, so there's a bunch of stuff on here that today, if you were to look at our literature or specific sort of integration, we do not support. But what we do support, and we have provided, which we just announced actually last week, is a component called Control-M Application Integrator. And this component is a tool that we have, that we're delivering to customers to, in effect, allow them to teach Control-M how to manage any application they have. As long as your application has an automation interface, command line, SQL, web services, whatever it is, as long as there is some way for us to say, hey, can you please run a job? Can you tell me the status of a job? Can you give me the output of the job? Can you kill your job? As long as it has those sort of basic rudimentary operations that we can access, you can use Application Integrator, which is a web design tool, to teach Control-M how to interact with that application. And if you are so willing, you can then share your integration on the Application Hub. And the Application Hub is intended to serve as a community for all Control-M users to let them share their work in designing integration and job types. And of course, that could be the first place to look if you want to find support for an application that we don't already support today. And so we feel with this tool and the capabilities that we offer, what we really have with Control-M is a platform for managing workflow. All of the other things that are generic that I talked about, determining success or failure, collecting output, managing historical data, forecasting, SLA management, all of those apply not only to all of the jobs that we create, but all of the applications that anybody will provide support for via Application Integrator. And so we feel very comfortable and confident that with the combination of capabilities we deliver today and Application Integrator, that we literally can support every single application that you might have for which you might want to run workflow in your environment. And just in case you didn't know, we are a platinum sponsor at the Hadoop Summit. We've been both here for the last several years as well as in Europe. We're very active in the space, and we've made a very substantial commitment to the Hadoop and big data markets. If any of you are familiar with BMC, we are, as I said, a very traditional sort of systems management and IT management company that has been around for over 30 years. And we believe that there's tremendous opportunity in the Hadoop and big data markets. And so we are here, and I think probably pretty much the only one of our ilk to be represented at this kind of a conference. So that's kind of all I wanted to say to you today, and open it up for any questions that you might have. Yes? The UI. Yes, the question was whether the UI runs on a browser. So we have a couple of different flavors. Our sort of power user UI is a thick client, Windows thick client. But we also do have browser-based UIs that have reduced functionality. Okay. Yes?
Hello.
Hi.
I have a technical question.
Sure.
Because you just mentioned about converting all the Oozie workflow into control M. So say I have a Oozie workflow that run like parallel pick, hive, or MapReduce job, and once it got converted into control M, is it still running the original pick and hive jobs, or MapReduce job?
Yes, absolutely.
Yes. So since it is still running the pick and hive and MapReduce job, say before you're using Oozie to run the parallel job. So what is the entry point? Do you still what is the entry point for the hive and pick or whatever MapReduce scoop jobs?
We submit jobs to Yarn.
Okay.
In a Hadoop cluster. I mean, you can also, for technologies that don't require Hadoop that can run independently,
Yeah.
and then they can run on a Linux platform basically. We would run those in that way. So we have support. We can run scripts. We can run any kind of executable or binary. If it runs on the OS directly, then we can run it that way. Or if it is, if it requires Hadoop and it's running in a Hadoop cluster, then we submit that request to Yarn. But you can go either way.
Yeah, because one thing about that, one part about one of the reasons that Oozie being like user not very friendly is every time it launch a job, it launch a mapper job, and inside any mapper node, it will launch the real job. But in this way, it actually solved the scalability issue, because if you're running 12 jobs at the same time, if you all launch on the same node directly calling hive and pick, sooner or later will be overwhelmed. Since hive, pick, and these jobs are blocking call, you will never exit the program until the query finish. So my question is for control M, like how did you launch those jobs? Because if you are still launching those jobs, whatever submit to Yarn from just one node, instead of like the Oozie's hacky way about running a mapper job only, a launcher job, then like wouldn't you go into the same scalability issue that if you have parallel job running, and then you're going to soon overwhelm one node, the node where you launch these jobs?
So I think it also depends where your pig script is residing, whether it's in the file system or whether it's on HDFS, but we are not the ones that are actually responsible for making the decision. So it's a matter of what scheduler you have defined in your environment as to how that's going to run. I don't think that it's a decision that Control-M has to make. But I'm not sure that I have the complete authoritative answer, so I'd be happy to take that away and get back to you.
Okay.
Okay? Yes?
Most challenge people have in using workflows or Oozie in that context is the time management of the workflows, as well as the coordination job and with bundles. To be able to visualize it, it's not very easy, because each of the workflow and coordinator job is in the separate files. So to picture this into a visualization it's a challenge, and how Control-M solve these problems.
Well, again, we don't use Oozie structures. We have our own mechanism for building the visualization and managing it. So when you convert, whether you convert or create with Control-M from inception, you are building that visualization graphically. That's what you're actually seeing. Each one of those rectangles or boxes represents whatever process you have defined for it. So you automatically get that visualization, both for definition as well as in execution.
In execution, I'm interested to find out in the workflows, because workflows can be either time-based or it can be data trigger-based, right? And how is the visualization is being conveyed in Control-M to indicate this section of the workflow is going to run periodically, or this part of workflow is going to run triggered by data?
Okay, so there's this is kind of detailed. I would have to show you an actual form, but there's where you can define. So a couple of things. First of all, we are not a DAG. Okay, you can actually define cyclic flows, but you actually define what is the running criteria, whether it's time-based, it could be, you can specify that you want to run something at a particular time, but we don't really suggest that. Generally, it's some kind of an event that is triggering the execution of something. It's not necessarily the creation of a file, but again, that's visualized in the flow where you have a file trigger followed by some kind of a process. When that file trigger criteria is met, then it will, you see the relationship, and that file trigger will then turn green, which means it's been met, and then the next workflow will begin. You also can inquire for every object in the sort of the flow chart as to when it's going to start. So you can, there's a display to show you what it is waiting for, whether it is time or files or predecessor jobs or other relationships. So all of that information is available, most of it graphically without having to actually drill down any further. And then there's other information that's available by selecting that object and looking at its properties. Okay?
Thank you.
Okay. And I think, am I out of time? Yeah, I'm out of time. Thank you very much, everyone. Unfortunately, going to have to go. I'd be happy to further conversations outside if you'd like.